we will move with the next session, and I will give the floor to Emma, who will explain to us the environmental and social acceptance module. I will, just before you start, Emma, maybe I place the module in the list here. So before that, we were at that in the SK module. After the SK module, the user can run the logistic and marine operation module, which will give you some operation plans and corresponding cost for installation, operation maintenance, and decommissioning as well. Then when you have done that, you are done with deployment design tools and you can move to assessment tools. In the assessment tools, you have 4 different modules. The first one is to estimate the system performance and energy yield. Second one, analyze the reliability, availability, maintainability, and survivability. The third one gathers the cost results from all the modules that have been run before and make some computation to estimate the system lifetime cost. And the last one, ESA, deals with the environmental and social acceptance results of the project. And this is it. And Emma will present this module. Emma, I will give you the right to present, and the floor is yours.
Okay, so you see this. And you should see my presentation, yes?
Yes, so perfect, thank you.
Thanks. Hi everyone, my name is Emma Araignous from France Energy Marine, and I will introduce you the last assessment tool, so like I said, NEL, that allows to evaluate the project in terms of environmental impact and social acceptance of a project. So the objective of the tool is to assess how all the choices made by the user in the design or the array configuration, etc., will have a potential impact on the environment at different level, and how the user can act on these choices to lower those impacts. So globally, the results of the tool can be useful to help the decision-making processes concerning the choice that minimize the global environmental impact of ocean energy project. So following the regulatory context of environmental risk assessment and socio-economic opportunities, the tool was structured into 4 different features representing 4 complementary assessments. First, the tool will evaluate the potential presence of endangered species in the area of implementation and provide some recommendation on surveys or mitigation measures that can be carried in the implementation site. The second feature assesses the environmental impact assessment of the design choices that were mostly made previously in the other tool of DTOceanPlus in terms of pressure existence and receptor sensitivity. We included a carbon footprint feature that conducts a life cycle assessment and will help the user to reduce its global warming participation. And to add to the carbon footprint assessment, we also included another feature, the social acceptance, which provides some insight on other relevant social concerns. So I will just take a few minutes before I do the demonstration to explain a bit more each of these features so that you understand how it works before the demonstration. So for the endangered feature, the endangered species feature, Ewan talked a bit about it, but what we did was to create a database for a selection of 26 species. So for that, we based our selection on the IUCN red lists and the presence of the species in European directive or international conventions. And this database includes maps that represent the mean annual distribution of the species on a half-degree grid. And so when the user will choose a location for the farm, the feature will look for the nearest coordinates to retrieve probability of presence of the 26 species. and we'll provide information on taxonomic information, IUCN status, and recommendation on the surveys for this type of species, and also give a first information on the main risk for this species and provide some recommendation on the mitigation measures associated with these risks. The second feature, so the environmental impact assessment, consists of a set of functions that are able to quantify and quantify the potential pressure generated by the array. So in DTOceanPlus, we used the concept of stressor receptors. So the pressure can be any type of impact that the array can induce in the environment. So for example, we consider 10 negative impacts from chemical pollution to collision risks, the footprint of the farm, and also we consider 3 positive impacts, so the reef and reserve effect and the resting place. For this feature, we propose 3 levels of output. So first, you have a global score of environmental impact for the project. So a negative one and a positive one, which will be basically the mean of all the negative impact and the mean of all the positive impact. You get also the detailed results of all the pressures at the array level, and finally score for the different technology groups. So we consider the electrical subsystem, hydrodynamic parts, station keeping, and marine operation separately, and we provide detail for the associated pressures for this technology and recommendation to lower the environmental impact. The third feature would be the carbon footprint. So here we are conducting a life cycle assessment for which, in DTOceanPlus, we wanted to translate the preliminary flows into midpoint indicators and to be able to situate a project among its relative concepts. So we follow the structure of the LCA processes defined by the standard ISO. Which basically describe 4 steps to follow to carry a life cycle assessment. So the first step is to define the objective and the scope. Like I said, we want to translate the preliminary flows into midpoint indicators. So for that, we used an attributional approach, which means that the processes that we use are average and fixed image of existing processes. And we considered 3 of the 4 levels of the International Reference Lifecycle Data System. So the array itself, the manufacturing, assembly, and processing activity, and all the marine operation, but excluded non-physical involvement, so the design offices or administrative services. The second step is to conduct the lifecycle inventory. So in ESA, we used 2 sources of inputs. Obviously, we use all the information that we can get from the other DTOceanPlus tools, a bit of information from the user, and also we have a local database that we created based on information from Eco Inventory to translate design information and materials into indicators. So for the assessment, we choose 3 midpoint indicators that are widely used for marine energy life cycle assessment: the global warming potential, cumulative energy demand, and the energy payback periods. For which we included also a comparison of the different phases between different DTOceanPlus projects and also between other energy or concepts. And for the last feature, this is a place where the user can find insight on relevant social acceptance concerns like the cost of consenting. So the user can evaluate the levelized cost of energy in the system life cost tool. And also we provide an information on job creation. So for now, we are providing the physical involvement in marine operation. That's the logistic and marine operation tool can provide to the tool. So I will go on with the demonstration. To exemplify the tool, I will use the reference model 1, but I will use an example of 10 devices because it was more interesting to evaluate the collision risk and so on. So I have 10 devices and I only do RM1 and not RM3 like navigate. So I believe you see. Yes. This is the dashboard of the environmental and social acceptance module. This tool is constructed into a basically straightforward way, like the two other tools that my colleague presented. So you have the home page of ESA, where you can create a project or load a project, and then you have the inputs, run module, and output section, and also, like the other one, the links to document or DTOceanPlus website. What we did was for the inputs, what we did was to separate the input into 4 categories that pretty much go along with the order of the DTOceanPlus tool, so that would be more intuitive for the user to fill. So we are using all well, not all, but a lot of the outputs of the other modules. So we wanted to have as little information to ask to the user as possible, so that we can carry the environmental assessment. So for the first, for each input section, there are different subsections, and in each of them you have a section, help section, where you can find some information that can guide the user to fill the information, and also information on why this input is required and for which assessment. So for example, here we say that we need the longitude and latitude, and that would be used for the endangered species assessment, so that we can retrieve the information on this, on this. And the user can also have access to the documentation if you want some more information on, for example, here, the endangered species. So you have all the principle and objective, the inputs, outputs, and everything is explained in details if this is not clear in the tool itself. So I will go along a bit to the inputs. So first we ask the user for farm information, like global information, which basically come from the site characterization tool that you explained before. So first we ask for the coordinates of the farm, some global information about project lifetime or levelized cost of energy. So like I said, the user can evaluate that with the SRC tool. We also ask for some description of the area. So what type of zone are we in? What is the depth, current direction, soil type, etc. This is also filled with the site characterization module. The initial state of environmental parameters is not something that the site characterization can provide. So we ask the user to fill this information only in complexity 3. That would mean that the user will need to be in a pretty advanced stage in the construction of the farm. So in the farm information, we ask for the initial state, so meaning this is the value of measurements before the implementation of the farm. And in the next section of device, electrical, and logistic information, we ask for measurements after the implementation of the farm for these environmental parameters. So to measure if there is some change, noticeable change between the before and after implementation. We also asked them information on the phishing regulation that is to be carried out in the farm. So if the user know that there will be complete prohibition of the fisheries, or if there is only the cast net fishing that will be prohibited, or trawlers, he can choose between those type of choices here. And if the user select the no restriction, that would mean that there will only be restriction just around the devices, the security regulation. Then we provide the user the opportunity to provide some more information on the protected species that can be in the area of implementation. So in the database that we created, we only have 26 species. This is more international species, and if the user has information on the very local species and he wants information to have an idea on the surveys or the mitigation measures that he can put in place for this type of species, he can add the species here. So for Tacoma, we know that there is this bird. It's a little plunging birds, and it's a resident in the area. So I add it to this section, and I can get some recommendation after in the endangered species feature. We also ask the user, this is filled by the user, if he has some information on different kind of receptors in the area. So maybe the type of benthic habitat. So here we know that in Tacoma, this is pretty much rocks and pebbles. So we know that the substrate is hard. So this is already filled. If the user has information on the particular habitat, or maybe if there is some birds, so here the medium diving birds are checked because of the bird that I filmed just before. Maybe if he knows that there are seals or some kind of bony fishes or electrosensitive species, he can fill the information here. If he does, it will help the tool to refine a little bit the assessment. And if he doesn't, it's okay. The assessment would be done anyway, but it will be less precise if we don't have information. So the next page will be information on the devices, and so the information here will come from machine characterization, energy capture, and also station keeping. So we have some basic information on the devices, so whether if it's a tidal or wake energy converters, if it's floating, the number of devices and their location in the farm. So this location will, for example, help with the collision risk assessment. We also ask for the dimension of the devices. So everything here is filled by the other tool. And we also ask, this is for the carbon footprint and the life cycle assessment. We ask the user to, no, not the user, sorry, we get some information on the materials that are used to construct the devices and the foundation from the other modules. So we have a list of materials. If the user wants to complete this list, he can just select another tool and provide the quantity that he will need to use. And also the user will have to provide information on whether the material will be brought back to land to be recycled or not. For the devices, this is what I was talking about before. You can enter some environmental measurements. So this is environmental measurements that are made after the implementation of the farm to evaluate whether or not there are more noise in the area because of the devices and more turbidity during the installation of the devices. Again, this is phishing restriction. So in this section, the user has to fill some, just the surface of security around the devices that is considered in the farm. And then we have the information on the foundation that would be provided by station keeping that Nel just presented. And so he is giving me materials, quantity of these materials, and also the footprint of this foundation and the colonizable part of foundation for the reef effect. For the third section of inputs, that would be electrical. So this is all provided by energy delivery and the user again. So we ask information on the annual energy produced. So that would be used for the social acceptance and also the carbon footprint. Again, we ask for the colonizer surface area of electrical component. Here it's at 0 because I said that the, I said that the cable will be buried, so there is no surface to be colonized. And also the footprint of electrical installation. And again, we go on with the same section, the phishing restriction around the cable. The user has to provide information on the surface of this phishing restriction, and also, again, the materials quantity, and the materials to be recycled. And again, the environmental measurements. So for the cables, we considered the noise, the electrical and magnetic field, and the temperature in case of a overheating of the cables in the area. And the last section of inputs would be the logistics. So we have installation, exploitation, and decommissioning, which basically gather the same information. So the tool Logistic and Marine Operation will provide this information on the number of vessels that will be in the area in the installation phase, the mean size of the vessels, the noise, basic noise of these vessels, the number of passengers that will be considered in this phase, so that we can provide it to the user into the social acceptance feature. Also the turbidity during this phase, and if maybe he has noticed a chemical pollution during this phase of installation, and the fuel consumption during the whole phase to consider that into the carbon footprint assessment. So when the user has all the inputs, so every category is complete, it can run the module, and I will go on directly to the results. So first we start with the endangered species. So we wanted to highlight that even though we don't find any species in this section, all marine birds and mammals are protected. So in any case, mitigation measures and surveys will have to be put in place, even though in DTOceanPlus we have not been able to identify any in the area. But in our case, you must remember that in the inputs I added this bird that I wanted to have some information on. And I see that here I can get some information on the main risk associated with birds in the area. So that would be the collision risks, and recommendation on mitigation measures associated with this risk. So here for birds, we give recommendation on the site selection to avoid where this is a corridor of migration, or maybe we encourage the use of a turbine shutdown on demand, and maybe encourage the awareness among ship pilots also. So we didn't find any actinophagy, and we find 2 sharks that potentially be present in the area. So that's a small probability of presence, but this is up to the user to consider or not these results, depending on the probability of presence that he wants to consider. But here you have some information on the taxonomic information of the species, and again we provide recommendation is here on surveys. So maybe you need to characterize electromagnetic field variation in the area, because sharks are very sensitive to that, and this is also the main associated risks. And for that we encourage to bury the cables at least 2 meter deep, for example, and so you have all the main associated risks. And the same for mammals. We found 3 mammals here, so with basically again a small probability of presence, but in if the user wants to carry surveys or mitigation measures, he has information on that anyway. So that would be example for the endangered species. For environmental impact assessment, so like I said, we have 3 levels of results. So first you have the global environmental impact assessment at the array level. So that would be the global negative impact into a scale of 0 to -100. So here our project has a score of -16. So that would be not very, that's not a good score, but that's not the worst, let's say. And a mean positive score, so from 0 to 50, and we have a score of 6. Then you have the details depending on the technology group. So for example, for the hydrodynamics technology group, so that would mean the devices, the different pressure that would be associated with this type of technology group would be energy modification, so the level of energy extraction. So here we have a score of -10 because the energy extraction was quite low, and we provide an explanation. So here we say, okay, the results, the score results of a moderate level of energy extraction, and we provide some general recommendation if the user wants to lower a bit more this impact. It can limit the number of devices, increase the space between the device, or it can go a little bit further and monitor the sedimentary evolution in the farm area. So for each technology group, you have all the pressures that that are associated with this technology group. So here also collision risk with the devices, the turbidity during the installation phase, the noise of the devices, and also the 3 positive effects. So reserve effect here, I put complete prohibition of fisheries in the area, so you have the highest score for this pressure. So meaning that I close to fisheries, so I cannot do more for this type of pressure. So this is there is no recommendation because this is the best. And also for reef effect, so we have a score of 10 because we have a pile for the foundation. So this is quite good for the reef effect, but some other foundation also have a more large surface for the reef effect. So you can do better. You can do better now. And so you have all of this for the different technology group. And at the end, you have the 3rd level of assessment. So here you have the detail for each of the pressure at the array level. So if you want just to know, okay, my what is the collision risks with the devices in the global farm, the global area, you will have a score of -24. So yes, that would be it for the environmental impact assessment. And then for the carbon footprint, so you have also 2 levels of results. So first, the global result for the whole project. So the global warming potential, cumulative energy demand, and energy payback period, like I said. You can compare to other source of energy. So here you have your project, and then you can compare it with other energy. So you have oil, biomass, wind. Okay, I don't see the name here because my screen is quite small, but you have all the name. If you want to see, we put the reference of all of these assessments. Okay, it doesn't work now, but you have the reference for all of these other energy to be really aware of the limits of the LCA that are used in DTOceanPlus and the limits that are used by the other assessments of the other energy, because this is to give an idea, but the values are not really comparable. You can also compare with other technology. So here you have example of tidal concepts, and you can compare yours with this one. So here we are a little high compared to others, and you can also compare with the energy payback period, and we are quite better in this area. After that, you can see the results per phases. So you have all the 5 phases of the life cycle of the farm that are considered in the LCA of DTOceanPlus, and the results for global warming potential, cumulative energy demand, and the energy payback period for the total life cycle. And in this section, you can compare with other DTOceanPlus projects that have a life cycle assessment that is done. So you will load another project and you can compare your 2 projects. So that can allow you to make some change in the concept of a farm and to compare if you have a better carbon footprint or not. So that can be very quite useful in the choice to minimize the global warming potential, for example, or cumulative energy demand. And at the end, you have the section of the social acceptance. So again, this part you have the number of jobs. So here, for now, it's only considering marine operation vessels crew, and also the cost of consenting, which will be the LCOE. So this is a place where the user can find some information on social acceptance concerns for public and or developers. And that would be it for the tool. Maybe I can give you